Chapter 2, Section 3, Digging Deeper, Sedimentary Rocks in Earth's Crust, Distribution of Sedimentary Rock. In the Investigate, you used several kinds of models. Your models simulated ways or processes in which sedimentary rocks form. You then looked at actual sedimentary rocks. Next, you analyzed data on a geologic map of your region and identified and located sedimentary rocks in your area. Except for a thin layer of soil and very young sediments at Earth's surface, Earth's crust is made of solid bedrock. Sediments are loose materials that have not been formed into rocks. The crust consists of a very wide range of rock types. However, sedimentary rocks are by far the most common type in the upper crust. If you could somehow take off the thin layer of soil and sediment from the top of the crust and look at the exposed bedrock, about 3/4 of it would be sedimentary rock. Over large areas of the continents, sedimentary rocks form layers called strata. See Figure 1. So let me scroll down so we can see Figure 1. Okay, here's Figure 1. The Grand Canyon is a striking example of layering in sedimentary rocks. Data about sedimentary rocks. The average thickness of Earth's sedimentary shell, 2.2 kilometers. The coverage of Earth's land area by sedimentary rocks is 80%. Sedimentary rocks as a proportion of the volume of the crust, 11%. Concentration of total sedimentary rocks on land, 70%. Concentration of total sedimentary rocks in the ocean, 30%. How sediment becomes rock. In many places, sediments are deposited for a long time. They become buried deep below Earth's surface. The pressure on the sediment increases. As a result, the particles are pressed together. This process is called compaction. Water solutions from deep in Earth can filter up through the pore spaces of the sediment. Materials precipitate from these solutions. They are deposited around the sediment particles. The material acts like a cement. This process is called cementation. Compaction and cementation cause the sediment to turn into a solid sedimentary rock. In Part A of the Investigate, your mixture of glue and water modeled the natural cementation process. Clastic sediments usually turn into solid rock deep under the surface. This usually occurs after many hundreds or even thousands of meters of burial. On the other hand, chemical sediments can become sedimentary rocks with very shallow burial. They can form from meters to a few hundreds of meters below the surface. Classifying sedimentary rocks. Sediments are deposited in many different environments. As a result, there are many different types of sedimentary rocks. Scientists have developed a classification system for these rocks. They have grouped them by features they find important. It helps them discuss the different types of rocks with each other. You looked at sedimentary rocks in the Investigate. You thought about how to put them into groups. Each person that makes a classification system decides on which features to use. For example, you might have chosen color, texture, roundness of grains, or other features. Did you find differences among your group members or between groups? If you did, you experienced exactly what geologists did. In the Investigate, you learned that the rocks can be classified as clastic, chemical, and organic. It is about the simplest scheme that can be used. There are much more detailed systems. However, they all use two main features. These are the composition and size of the sediment particles. Clastic sedimentary rocks. Clastic sedimentary rocks are made of fragments or sedimentary particles called clasts. The clasts are eroded from other rocks. Conglomerate, sandstone, siltstone, mudstone, claystone, and shale are clastic sedimentary rocks. Clasts are classified according to their size. The smallest clasts are too small to see without a microscope. They are called clay. Clasts with sizes between clay and sand are called silt. Claystone consists of clay-sized particles. Siltstone consists of silt-sized particles. Mudstone consists of a mixture of silt-sized and clay-sized particles. When a claystone or mudstone breaks into small flat chips, it is often called a shale. Sandstone is made of sand-sized particles. Conglomerate is made of gravel-sized particles. The size of the particles ranges from small pebbles to large boulders. The particle size usually reflects the strength of the... I don't know why my side scroll bar isn't coming up, but I'll figure that out later. The particle size usually reflects the strength of the medium that carried the sediment. Pieces of gravel are much larger than tiny clay particles. Therefore, faster flows of water are needed to move them from where they originate to where they are deposited. So you have the term. Okay, so you have your term in the first column, you have your name in the second column, and then your diameter in the third column. All right. Chemical sedimentary rocks. Sometimes water cannot hold all of the material that is dissolved in it. When this occurs, some of the material comes out of the solution as solids. This process is called precipitation. It can happen when some or all of the water evaporates. It can also happen when the water is cooled. Chemical sedimentary rocks consist of materials that have precipitated from ocean water or lake water, as in Figure 3. So, evaporation of a glacial lake formed gigantic salt flats at Lake Bonneville in Utah. In Part A of the Investigate, you ran a model of the deposition of a chemical sediment. You did this by allowing a saturated saltwater solution to dry. The salt crystals that formed precipitated out of the solution. Limestone is the most common chemical sedimentary rock. It consists of the mineral calcite. This is a calcium carbonate mineral with the formula... Okay, calcium carbonate. All right, some of the calcium carbonate is precipitated directly out of seawater. Some is precipitated by marine animals to make their shells. Dolomite is another common chemical sedimentary rock. It consists of the mineral dolomite. The mineral and the rock have the same name. Its chemical formula is gypsum and halite are also precipitated out of solution. They are also called rock salt. They form when solvent evaporates. The concentration of the solution then increases. At some point, the concentration is enough for the rock salt to precipitate out of the solution. Areas with arid or dry climates are where intense evaporation is most likely to occur. Water that contains dissolved minerals can be looked at as a system. The system is nothing more complicated than a solution of water and other chemical ingredients. If conditions in the system do not change and nothing else happens, then the system is in equilibrium. However, if something changes, then the water may change and disequilibrium occurs. For example, if the temperature of the water becomes warmer, then evaporation at the surface will increase. As more and more water is lost from the system by evaporation, then the relative concentration of dissolved minerals in the water increases. This occurs because the amount of water decreases while the amount of dissolved minerals stays the same. In Part A of the Investigate, you saw that once the water volume in your salt solution reached a critical lower level, then salt began to precipitate. The system had shifted to a new behavior, in this case, precipitation. Precipitation of salt lowered the concentration of dissolved salt in the solution. Consequently, the system returned to a previous equilibrium where the total concentration of dissolved salt in the water was below the maximum concentration. Precipitation now stops until a change in the system causes saturation again. Organic sedimentary rocks. Hold on, I think I figured out how to get this scroll bar back. Yep, there it is. Okay. Organic sedimentary rocks. Organic sedimentary rocks are made of organic materials. Coal is the best example. Coal forms when plants in swamps with a lot of vegetation die and are buried by the remains of later plants. The plant material becomes compacted. Over time, the weight of overlying sediment turns the vegetation into rock. The first material to form is called peat. Peat is shown in figure 4. All right, let's take a look at that. Okay, figure 4. All right. I'm hoping we can read and refer to the figure at the same time. Here we go. It has not, okay, so peat has not yet been buried deeply. Peat is used by humans for fuel and for agriculture. With time and greater compaction, peat is converted to lignite or brown coal. With further compaction, bituminous coal or soft coal forms. Approximately 35 meters of original plant matter is compacted to form 30 centimeters of bituminous coal. Deeper burial results in greater amounts of heat and pressure, which causes chemical and physical changes to the plant layers. As oxygen is removed from the plant material, the coal becomes increasingly rich in carbon. The most deeply buried and most carbon-rich coal is called anthracite or hard coal. Its main use is for heating homes. So figure 4, let me scroll down a little bit. Okay, figure 4 shows that in Ireland, peat harvested from bogs is often used as a source of fuel. Alrighty. Sedimentary environments. Sedimentary rocks are formed from sediments that are deposited in various places at Earth's surface. For example, limestone is usually deposited in a shallow ocean. That's why we have limestone all over here, all over Rock County, because this area, southern Wisconsin, northern Illinois, this all used to be part of a shallow ocean, okay? Alrighty. Sandstone can also be deposited in a shallow ocean. That's also why we have a lot of gravel pits and sand pits around here, a lot of quarries, where they're able to pull sand from and sell it. All right. However, it can form in a beach, desert, or river as well. Let me back up because I talked a lot. Hold on. Sedimentary rocks are formed from sediments that are deposited in various places at Earth's surface. For example, limestone is usually deposited in a shallow ocean. Sandstone can also be deposited in a shallow ocean. However, it can form in a beach, desert, or river as well. Coal is usually formed in swamps. A sedimentary rock can therefore tell you something about the environment in the past. Each rock tells a story about the geologic environment in which it was formed. However, it may not be easy to read that story. Percentages of sedimentary rock types on continents. Okay, shale, there's 50% on continents. Sandstones, 24% on continents. Carbonate rocks, 24% on continents. Evaporites and other, 2% on continents. All right. Sedimentary layers may be found near an ocean. This means that the area was most likely below sea level in the past. Sedimentary layers may also be found in the middle of a continent. This may mean one of two things. The area might have been low relative to nearby mountain ranges. The sediments that cover the low area were washed out from the mountains by erosion. You will learn more about surface processes in the next chapter. The other possibility is that the area was covered by a shallow sea. The other possibility is that the area was covered by a shallow sea in the past into which sediments were deposited or formed from ocean water. So that's where you get your Devil's Staircase, that's where you get your Magnolia Bluff, and a lot of the different geologic features that we have here in southern Wisconsin, Rock County. All right. Sedimentary rock units. Early geologists believed that sediments were laid down in uniform sheets over large areas of Earth. This concept is referred to as layer cake geology. Geologists now understand that at any given time, different kinds of sediments are deposited in different places. At times, these deposits are very close together. Different sedimentary rock units can be exposed in the same area of land surface. They might consist of conglomerate, sandstone, shale, or limestone. However, just because they represent different rock units, you should not assume that they are all of different ages. In many places, such units can be of the same age. They were deposited in different environments at the same time. Sedimentary rock units usually have a width, lateral extent, that is much greater than their thickness. They typically range in thickness from tens of meters to thousands of meters. Their lateral extent can be hundreds of kilometers. Kind of like that Magnolia Bluff. I mean, parts of it are just miles and miles of sandstone, and then you think about Devil's Staircase, that's miles and miles of limestone. So that's kind of what they're talking about. Sedimentary rocks and climate. Sedimentary rocks can tell you about past climates. For example, sandstone that was deposited as desert sand dunes records a time when the area was dry. Protective vegetation would have been lacking. Limestone suggests deposition in warm, shallow oceans. Coal forms in tropical to subtropical climates. Ancient coal is found in Antarctica. This suggests that the climate has changed over time in the Antarctic.